Assalamualaikum warahmatullahi wabarakatuh. Today I will be proposing our enterprise network proposal design for Nextech manufacturing. Our team members consist of Muhammad ADIB RAJAIE, Muhammad FIRDAUS, Muhammad Haziman and NAIM IMTIYAZ. For Nextech manufacturing company background, Nextech is a medium-sized electronic manufacturing company which consists of two buildings. First is the HQ located in Shah Alam. Next is the distribution warehouse located in Port Klang. Nextech uses technology like ERP, inventory management, and voice over IP system. It requires continuous communication between HQ and also warehouse to fully function. The current problem identified for this company is that the network congestion, the flat architecture, the weak security, there is no VLAN segmentation, there is no secure connection between HQ and warehouse, and it is very difficult to expand in the future. For the requirement and objective, first is our objective is to design secure and scalable hierarchical network architecture. Next is to implement IPsec VPN between HQ and warehouse. Moreover, is to implement VLAN segmentation, inter-VLAN, and also quality of service. Next is to enhance the security by implementing firewall, ACL, port security, etc. Next is to adopt a unified voice over IP telephone across all sites. Last is to design centralized management and a proactive management. And our objective must fulfill the requirement of reliability, availability, security, scalability, and manageability. For the current network topology for Nextech company is that the existing architecture is a two-tier switching architecture, which is a logically flat network. There is no VLAN segmentation, and the distribution warehouse connected through the HQ using a basic wide area network link. So there are a few current limitations that have been addressed by our team. Is that first, all departments share one broadcast domain. High broadcast traffic may lead to network congestion. There is no wireless access point for all departments. No implementation of ACL or port security, very weak security. No voice over IP communication system, and it is very limited scalability and security. It is not a future-proof network topology. So the current network lacks VLAN segmentation, advanced security, and scalability, making it unsuitable for future business growth. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. I am Muhammad FIRDAUS bin SYAHRUL and I will be explaining to you our network design to fix the problem. So we are using the 3-layer hierarchical architecture, which is a core, distribution, and access layer. The headquarters will connect to the distribution warehouse through an IPsec site-to-site VPN, so all the traffic between both locations stays encrypted and secure. We are also segmenting the network into 10 VLANs, and the whole design supports wired, wireless, and VoIP communication. The key features include high-speed inter-VLAN routing, department-based segmentation, secure communication between HQ and warehouse, and scalable and modular network design. So next, in our proposed design, the core layer is the backbone of the network that handling high-speed inter-VLAN routing and connecting our servers and WAN, while the distribution layer aggregates traffic from all the departments and offers our access control list. Finally, the access layer is where end devices connected and where the port security is also implemented. So we have split the network into 10 VLANs, where each department has one VLAN plus a guest VLAN that's fully isolated and dedicated voice VLAN with QoS for our IP phones. Each VLAN has its own subnet, and all inter-VLAN traffic is routed and filtered through the layer 3 core switch. Moving to the physical side, this is a two-site design. The main manufacturing plant is in Shah Alam, And the distribution warehouse is in Port Klang. Both flow has a core layer in the server room and distribution access layer spread across the department. All the critical infrastructure like core switches, routers, firewall servers located in the HQ server room, site-to-site connectivity, and our network design support scalability and reliability. Next, here's the actual floor layout at the main plant. The upper floor hosts the IT department, server room, and production, while the lower floor has a quality control, finance, HR, and procurement. Each department has its own rack with a Cisco Catalyst access switch connecting desktop IP phones, wireless APs, printers, and manufacturing terminals. All these access switches connect back to the Catalyst 3615 core switch in the server room using fiber optic backbone links, while the Cat9 UTP handles the connection within each department. This setup gives us physical separation between office and production areas, centralized management room to scale later. Next is the server room layout. The server room is the heart of the network. It houses the edge router, firewall, core switch, and access switch, and server like ERP, database, file, and backup. The design advantages improve physical security and centralized IT infra management, hence it simplify administration and monitoring. And finally, the warehouse side, it keeps simple by design. Just one dedicated rack holding a Cisco router for the IPsec VPN back to HQ and a switch connecting all warehouse devices. But the real value here is the benefit, which have everything centralized in one rack, means simplified cable management, better equipment security, and easier maintenance if something goes wrong. It also means the warehouse can grow for more workstation, IP phones, or access points can be added later without needing any major changes to overall network design.
My name is Muhammad ADIB RAJAIE ABDUL RAHIM. Next, I will explain the internet working devices and use in our proposed network. Our network uses enterprise level Cisco devices to provide high performance, security, and reliability. At the headquarters, the Cisco ISR4331 router provides internet connectivity and establishes a secure VPN connection with the distribution warehouse. To protect the internet network, we use the Cisco ASA5506X firewall, which filters incoming and outgoing traffic and prevents unauthorized access. For the Cisco Catalyst 3650 Layer 3 switch, act as the core switch. It performs inter-VLAN routing, manage quality of service or QoS, and serve as the backbone connecting all departments. Each department uses a Cisco Catalyst 2960X access switch to connect computers, printers, IP phones, and wireless access points. This switch also support VLAN, port security, and power over internet. Finally, Cisco 9120 as access points provide Wi-Fi 6 wireless connectivity, while Cisco IP phone 7821 devices are managed centrally by CUCM for efficient VoIP communication. Now I will explain the LAN and wireless architecture of our network. Our network combines both wired and wireless connections to provide daily business operation. The wired network uses Cat6 UTP cables to connect end user devices, providing gigabit internet speed. Meanwhile, the backbone between the server room and departmental switch uses multiple mode fiber optic cables, which offer higher bandwidth and lower latency. We also implement IEE 802.1q VLAN trunking to separate traffic between departments while allowing multiple VLANs to share the same physical connection. For wireless connectivity, we deploy Cisco Wi-Fi 6 access point across key departments. Each access point broadcasts two wireless networks, one for employees and another guest network that only allows internet access. In addition, Power over Internet or PoE powers IP phones and access points through internet cables, reducing installation costs and simplifying deployment. Finally, quality of service or QoS prioritizes voice traffic over normal data traffic to ensure clear and uninterrupted VoIP calls. Lastly, I will explain the one service provider and secure connection between both company locations. Our proposed network use Telekom Malaysia Metro Internet to connect the headquarters in Shah Alam with the distribution warehouse in Port Klang. Internet provides a dedicated fiber optic connection with high speed, low latency, and reliable performance. To protect all communication between the two sites, we implement an IP site-to-site VPN. The VPN works in two phases. Phase 1 use IKEv2 to authenticate both routers and establish a secure tunnel. Phase 2 use ESP or encapsulation security payload to encrypt all business traffic. For stronger security, the VPN use AES256 encryption, SHA256 hashing, different HALIM group 14, and a pre-shared key for authentication. As a result, sensitive information such as ERP data, inventory records, and VIP communication is securely transmitted between both locations, allowing them to operate as if they were on the same private network.
Now I'm going to explain about network security architecture. We adopt defense-in-depth strategy by implementing multiple layers of security protection to ensure confidentiality, integrity, availability, and business continuity. For the first technique, we use boundary protection and access control list. It is configured on layer 3 core switch to control inter-VLAN communication and limits the interdepartmental communication. For instance, IT department, which is VLAN 60, is allowed to manage and troubleshoot all the network segment, while production, VLAN 10, is being denied to access data from finance. For the second technique, we use layer 2 port security and device hardening. It is applied to secure switch port and prevent unauthorized access, while reducing layer 2 attacks. For example, we only use 2 MAC address per IP phone and we disable unused ports. We move to the network management. It is essential to ensure proposed network operates well. It is being divided by 3 parts. For the first one is network monitoring. SNMP3 is configured on all networking devices to provide secure monitoring with authentication and encryption. For the network administration and maintenance, remote admin is performed using Secure Shell version 2 to protect information, while preventive maintenance is done by updating Cisco software, backup routers, and switches. And for the last part is fault management and performance optimization. We monitor physical and logical network faults by reviewing syslog and SNMP alerts for rapid issue detection. For conclusion, our network proposal provides Nextech manufacturing Sdn Bhd with a secure, reliable, and scalable system because it is used 3-layer hierarchical network design to improve performance and management. The network also divided into 10 VLANs to enhance security and reduce traffic issues. For communication, a voice over IP system with a quality of service ensure clear communication, while a guest VLAN keep visitor access isolated. Several security measures like firewalls, access lists, secure shell, and VPN help protect the network. Finally, monitoring tools like SNP-V3 and syslog help maintain stable performance. Overall, the design is secure, efficient, and ready for the future expansion. That's all from us. Thank you.